Concrete sinks. Every kid knows that. Drop a chunk of concrete into water, and it goes straight down. No debate, no mystery. Gravity wins. So when the United States started launching full-sized ships made of concrete in the middle of World War II, everyone assumed the same thing would happen. They expected them to sink. Instead, these massive gray monsters slid into the water and stayed there, floating. And that was the first moment when people realized something was very wrong, or very brilliant. This wasn't a prototype, not a joke, not a one-off experiment. The US government ordered entire fleets of concrete ships to be built, launched, and sent into active wartime service. And no, this wasn't desperation. It was calculation. Here's the part that makes this story uncomfortable. The engineers who approved these ships knew how absurd it sounded. They knew concrete was associated with bridges, bunkers, and buildings, not the open ocean. But the math told a different story. And in war, math often beats intuition. Because the real reason these ships existed had nothing to do with innovation, and everything to do with panic. By 1942, the war at sea had become a logistical nightmare. Steel was disappearing faster than it could be produced. Every ton was being fought over by tanks, aircraft, submarines, and artillery. Shipyards were overloaded. Schedules were collapsing. And the ocean didn't care about excuses. Cargo still had to move. Fuel, ammunition, food, vehicles. Entire armies depended on ships that didn't exist yet. So the question wasn't, is concrete a good material for ships? The real question was, what do we build ships from when steel runs out? That's when an idea resurfaced, an idea that most people had forgotten for decades. Concrete ships weren't new. They had existed quietly since World War I. Small, experimental, mostly ignored. But now, under extreme pressure, that forgotten idea was dragged back into the spotlight, scaled up, reinforced, and pushed far beyond what anyone was comfortable with. Engineers didn't try to make concrete behave like steel. They leaned into what concrete actually does well. It handles compression. It resists corrosion. It can be poured into massive shapes quickly. And when shaped correctly, it can displace a terrifying amount of water. That last part was the key. Because once you understand why these ships floated, the design starts to look less insane and more inevitable. The hulls weren't solid blocks. They were hollow, reinforced shells, thick, heavy, and enormous. Their weight was massive, yes, but their volume was even greater. And volume is what water responds to. When the first of these ships touched the ocean, spectators watched closely. Some expected cracks. Others waited for the slow, embarrassing descent beneath the surface. It never came. The ship settled. The waterline stabilized. And against every instinct people had about concrete, the vessel behaved like a ship. That moment changed everything, because now the question wasn't, will it float? It was, how many of these can we build before someone tells us to stop? And no one did. But floating was the easy part. What came next nearly killed the entire program. Once the first concrete ships proved they could float, the program crossed a dangerous line. Because now the question wasn't theoretical anymore. It was industrial. The US didn't build one concrete ship. It built dozens. Full-sized cargo vessels, tankers, barges, massive gray hulls stretching longer than football fields, poured into steel molds like floating fortresses, each one weighing thousands of tons before it ever touched water. And here's where the story turns. Floating was never the hard part. Moving them was. Concrete ships had a problem steel ships didn't. They were slow, not slightly slower, painfully slower. Concrete hulls were thicker, heavier, and far less forgiving in rough seas. They didn't flex the same way. They absorbed punishment differently. When waves hit them, the impact traveled through the structure like a dull, heavy punch. They survived. But they complained. Engines strained. Fuel efficiency collapsed. Maneuverability suffered. These ships weren't graceful. They were stubborn. and stubborn things survive wars better than elegant ones. Because despite all of this, the Navy kept ordering more. By 1943, concrete ships weren't experimental curiosities anymore. They were part of the logistics backbone. They carried fuel, ammunition, construction materials, entire prefabricated ports. They were never meant to chase submarines or win battles. Their job was simpler and far more dangerous. They had to exist. Concrete ships operated where steel ships couldn't be spared. When steel hulls were needed for frontline combat, concrete quietly filled the gaps behind the scenes. No glory, no headlines, just relentless, ugly utility. But the ocean had its own opinions. Concrete doesn't corrode like steel, but salt water is patient. Microcracks formed. Repairs were constant. Crews learned quickly that these ships demanded respect, not admiration. And then came the storms. In heavy seas, concrete ships revealed their true nature. They didn't slice through waves. They endured them. Every crossing became a calculation. How much punishment could the hull absorb before fatigue won? Some made it, some didn't. But here's the uncomfortable truth. Even when they failed slowly. No catastrophic snaps, no dramatic breakups. Concrete ships cracked, sagged, and surrendered inch by inch. That bought time. Time for crews to escape. Time to salvage cargo. Time steel didn't always give. As the war shifted and steel production recovered, the logic that birthed concrete ships began to dissolve. They were expensive to maintain, inferior in performance, and politically awkward. Because admitting they worked meant admitting how close things had come to collapse. By the end of the war, orders stopped. Concrete ships were quietly retired, sold, or repurposed. Some were sunk intentionally. Others became breakwaters, docks, or artificial reefs. And a few were simply abandoned, left where they drifted. Which raises a disturbing question. If these ships were such a temporary solution, why do some of them still exist today? After the war, concrete ships were supposed to vanish. They were never meant to become landmarks, never meant to last, never meant to be remembered. They existed for one reason, to buy time. And once time was no longer scarce, the world moved on. Steel returned, shipyards normalized. The emergency that justified floating concrete quietly evaporated. Concrete ships became an embarrassment of sorts, a reminder of how close industrial systems had come to failure. So the solution was simple. They were removed. Some were sold for scrap. Others were deliberately sunk. Many were stripped, hollowed out, and pushed into roles no one would romanticize. Breakwaters, docks, static platforms. Concrete ships didn't die heroic deaths. They were reassigned. But here's the problem. Concrete doesn't rot. Steel rusts, wood decays, paint peels, machinery fails. Concrete just waits. And in several places around the world, these ships refused to disappear. One of the most famous examples still sits partially submerged near Galveston, Texas. A massive concrete hull, cracked and broken, yet unmistakably intact. Locals pass it without thinking. Tourists photograph it without understanding what it is. A ship that was never meant to survive the war, surviving the century instead. Others were absorbed into coastlines, becoming part of harbors, reefs, and shore defenses. Fish moved in. Barnacles took over. Nature didn't care that these objects were once considered absurd. It accepted them. And that's the final irony. The ships that existed because steel ran out outlasted the steel age itself. So why didn't concrete ships become the future? Because war rewards what works now, not what works best. Concrete ships were heavier, slower, less efficient, harder to adapt. They solved one specific crisis extremely well, and almost nothing else. And once that crisis passed, they lost their purpose. But that doesn't make them a failure. It makes them something far more uncomfortable. Proof that when systems are pushed hard enough, the rules people swear by start to bend. Concrete doesn't belong at sea. Except for the times it does. Next time you see a photograph of something that looks wrong, Too big, too crude, too unnecessary. Don't assume it was stupidity. Assume it was pressure. Because history isn't shaped by elegant ideas. It's shaped by the ones built when time, resources, and better options were already gone. If this kind of history matters to you, you'll want to see what comes next.